Hello and welcome back to the channel. This is Abhinav. So in this video, we are going to discuss about the problem A, B and C of Codeforces Round 812. So the first problem was a bit easy one. The second was also easy problem, means it was based on a simple observation that how we have to basically means we have to just check that the given array which is given to us contains the value of that function minimum or not. We will discuss them when we will go to the problem. The problem number C was also just a observation based problem. We have to, it was just a combination of implementation, how we have to implement it, because the logic was something which you have to think of and then we have to implement it. Okay. The problem number D, I have also attempted that I was not able to solve this problem. But yeah, I think that I am very close to it. I will just try it once more after this video, and then if I will be able to solve this problem, then I will upload this video, and also I will, you can just check the channel if I will upload this full video. Okay, great. So in this video for now, we will just discuss the first three problems. Okay. So if we move towards the problem of one, so which is a simple traveling salesman problem. So let me just tell you some things. Okay, the thing is that there is a coordinate plane given to you. So let's take a coordinate plane that this is a given coordinate plane. Okay, and currently you are at this position. Okay, that is what is given to you. You are at this given position. Now what you have to do, what we have to do is that we have some given points. Okay, for example, this is a point, this is a point, this is a point, this is a point. These all the points were in the, should be in the x and y axis. They all are in x and y axis. They are not in any other, like these are not possible. Okay, this is not the case. The points are always in the x axis or y axis. That's the case. Okay, now the thing which we have to observe is that uh, we have to move, and we have to just cover all the points, and then we have to again, we have to start. Okay, after start we have to cover all the points. Okay, and then we have to again go back to the start position. We have to end it at the start. So we have to start, basically we have to start from 0 comma 0. Okay, and then we have to end at 0 comma 0. That is what is given to us. So first, obviously, what we will do, we will just go there at a particular position. We will iterate at a particular direction. For example, we are going first to the positive x-axis. This is positive x-axis, x positive. This is x negative. Okay, this is y negative. This is y positive. Okay. So first we are moving towards the x positive. Okay, we have just gone there. After that, what we will do, we will try to not repeat a path, because if, for example, if we have just first traversed till move till x positive, then if we will then move to x negative, we are repeating this particular path. So repeating, we will try to minimize this thing. We don't want to repeat anything. Okay, so then what we will do, that it is also okay, it is also okay, it is a kind of thing. What we will do, we can do anything. Means the thing is that we have to start, then we have to move to a particular position, then from that position we can go anywhere else, then anywhere else. That is what we can do. So what we can do, we can just start from here, then go again here, then go there, again to origin, then here, then again to origin, then here, then again to origin. That is what we are doing. That will be the minimum number of points that we have to cover. We will just go to the last point at a particular direction, then again to the origin, then to a point, then again to our origin, then to a point. It's like a flower. Okay, so basically, if basically for, let's say that for the farthest point in each direction, means for example in positive x axis, this is the maximum point. Let's name it A. In this positive y axis there is a B. This is the maximum point, farthest point. Here it is C, here it is D. So basically our answer will be, we have to first move a distance, then again a distance. So here it is 2a, then again C D distance, it is 2D, it is 2C, and it is 2B. This is what we have to do. Okay, So I have just this is what I have also done, okay, in my code part. If you will just check out my code, I hope that it is passed correctly. Okay, so to system this is not yet started, I think, otherwise it should have passed. Yeah, pending. Okay, no problem. So yeah, what I have done is, let me just tell you that first what I have done, I have just taken the numbers, and for points at x-axis I have stored in a vector x, and other I have to store in a vector y for the points in y-axis. Then I have sorted the vector x and vector y. Then here is the value. This x minimum is basically the minimum, this is x minimum. If I will just tell you, this is the x minimum, the point which is in negative axis farthest from there, and this is x maximum. Similarly, this is y minimum, sorry, y maximum, and this is y minimum. So what we have to do is that we have to go and then come back to origin for all that points till there. Okay, so and also there is also a case that there is a corner case, and there is a case also that for example, let me just take another coordinate axis for better understanding. This is a coordinate axis. For example, there are no points in this negative axis. There is no such point. The points are like this, this, and this only. In that case, we'll just go there, come back, go there, come back, go there, come back. Getting? This is what we have to do. For example, there is no point in negative y-axis also. In that case, we'll just go, come, go, come. So this is also a case. This is also a case. Okay. So obviously, if the first element of our x vector is negative, that means there is a point at negative x-axis. Okay, negative x-axis. So we are just taking 2 of that. And if the last element is positive, that means there should be a point at positive x-axis. We are taking this. Similarly, we are doing that for y-axis also, and then we are just printing the answer. Okay, that is what we are doing. So I hope that you have got this problem. Now we will move towards the next problem, which is, I think, problem number B. Okay, yeah. So problem number B is again a very amazing problem. So let me just explain you that thing. So it is saying us that we are considered an array A of n positive integers, and in that case what we do is that we have to select 2 indices L and R, then decrease all elements of that subarray. So basically we have to first select a subarray, then we have to decrease all the elements of that subarray by 1. All the elements of that subarray by 1. Okay. So the case is that let's call fa be the minimum number of operations needed to change. So this number of operations are stored in a, for example, this is a function fa. Now we have to determine that for a given array, if we consider all the permutations of that array, then this function fa should always be less than equal to the other permutations. Basically, the number of operations required for that array should always be less than which can be required for the other permutated array. Let's take an example. Okay, let's take an example to understand this thing more clearly. Okay, for example, the array given to us is 3, 2, 2, 1. In this case, first we will take the whole array. We will subtract 1 to all elements. It will be 2, 1, 1, 0. Then we will take this much. It will be 1, 0, 0, 0. Then we will take this much. It will be 0, 0, 0, 0. So basically, it is taking 3. It is taking 3 operations. But for example, if I am taking another, if I am taking another case, let's say this is the case. Just a minute. Yeah, like this is the case. Okay, in this case you can see that number of operations required will be, first take the whole, so it will be 1, 2, 0, 1. Then we have to take this much only because this is 0, we can't make it. It will be 0, 1, 0, 1. Then we have to take this one, it will be 0, 0, 0, 1. Then this one, okay, it will be 0, 0, 0, 0. Okay, so there are 1, 2, 3, 4 operations required. So you can see similarly for all the other permutations of this array, the number of operations will be either equal to or greater than 3. So that means that this is a good permutation. This is a good array. That is what we have to find. That the given array is good or not. Fine. So there's a case. The case is that we will ensure this thing that in every operation we are taking all the remaining elements in the subarray. For example, in this case you can see currently there are 4 elements. So in the first operation we have taken all the 4 elements as our subarray. In the second case there are 3 left elements. So we have taken all the 3 elements in our operation. The next case there was only 1 left element. So I have taken that in the subarray. So if this is the case, this thing is happening, that means we are not wasting any operation. For example, in this case we have wasted one operation. In that operation, in the second operation, we have just decreased the value of this 1 and 2. We have just missed this one. And that is why one operation has been increased to decrease this 1 to 0. So we will try कि कोई भी जो है नंबर बचे ना, जब भी हम लोग ऑपरेशन में जितने भी नंबर्स हैं रिमेनिंग सब आ जाएं. And how it will be possible? It will be possible that firstly the boundaries of the array should be 0, should become 0. The boundaries of the array should become 0. First the boundaries of the array should become 0. That is the case. For example, if the given case is array is 5, 1, 4, 4, we are making it take the whole subarray, then it will make it 4, 0, 3, 3. We are just decreasing all the numbers by 1. So you can see that in the next operation we can either take this thing or this thing. There is no way that we can take all the 3 numbers 4, 3, 3 at once. So यहाँ पर क्या होगा, तुम लोग ये ले सकते हैं या तो इसको डिक्रीज कर सकते हैं. But if the question is something like this, in that case it will be 4, 3, 3, 0. In that case we can take this whole as at once. Then again 3, 2, 2, 0. Then again this whole at once. Otherwise in this case, now there are 2 separate arrays. We have to apply operations to separate array. First this array, it will become 4, 0, 2, 2. Then again here. So like this. So we will ensure that in boundaries there are always minimum element. So what we will do, for example, how we will ensure that in boundaries there are always smaller elements, So first of all we will, for example, the array given to us is 1, 5, 6, 4, 3. So to ensure that all the smaller elements are in boundary, what we will do, we can use DQ. I have used DQ basically, that I am saying. We can also use 2 pointers. Okay. So what I can do, DQ is something like 2 pointers. In DQ also we have 2 pointers. First the front pointer and the back pointer. So we will have a front and a back pointer. Now we will solve this array. So it will become 1, 3, 4, 5, 6. Or let's take a 2 also here. Okay. A 2 also here. So it will be 1, 2, 3, 4. Okay. So first element is 1. We will check that is this 1 present at border or not. Yeah, it is present at border. So what we will do? We will just increase our pointer. In DQ we can remove this and then our pointer will be here. This one has been taken. Now there is a 2. 2 is also in the border. Let's update. 3 is also in the border. Let's update. 4 is also in the border. Let's update. Now 5 is also in the, this is a remaining subarray, na? In this subarray 5 is in the border. Now 6 is also in the border. Means this is a valid case. Means this, not this. Yeah, this is a valid case. In this way, no operation will be wasted. For example, the case was like this, 4, 1. In that case, if we will solve it, it will become 1, 4, 4, 5. And then when we will check the case, 1 is not present in the border. These are our border elements and 1 is not present here. So we will just return no. This is the case. Okay, this is the case. So if I will just move towards the code part to explain this thing. Okay, so yeah, here I have taken a DQ. Okay, and then I have just pushed all the numbers in a DQ. Then I have taken DQ means, yeah, obviously DQ is not very effective, means it is taking extra space. We can also do it by 2 pointers approach. Okay, then I have sorted the vector and then what I've done that I've just checked that if the particular in a sorted vector, the element is present at the border or not. Means if it is present at the front of the DQ or it is present at the back. If it is present, we are just popping it. Otherwise, we are returning no. We are returning okay. All yes. If all elements are in border, then we are just returning yes. Okay. This is what I am doing. So great. Now let's move towards the problem number C, which is like build permutations. So in this problem, it is saying that we are given with a 0 indexed array of size n, which is called good if for all indices ai plus I is a perfect square. So it is saying that we have to create a permutation array. Permutation array means from number 0 to n minus 1, we should create a permutation of this array, which is good. So for each given n, we have to create such permutation so that it's the value of every ai plus I is a perfect square. Let me just explain you what we are doing here, what we are saying, okay, what we have to do. So it is saying that for example, we have value of n is equal to 6 or let's say 7. So let's create an array of 7. 7 means from 0 to 6. 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. So what do we want? That here's the number should be like that ai plus I should be a perfect square, should be a square of a particular integer, should be a perfect square. Okay, that is what we are wanting, and we have indices. So let's take that if we have to, let's say there is a number ai, let's say there is a6. So what should be the value of 6 a6 so that a6 plus 6 will become a perfect square, a perfect a perfect square. Obviously this whole value is always greater than or equal to 6, always. If we will take a6 is equal to 0, in that case also will be 0. So the value of a6 plus 6 will be always greater than or equal to 6. So that means our perfect square will also be greater than or equal to 6. So we will always take such perfect square so that it is greater than 6. So a perfect square which is greater than or equal to 6 is 9. So what we will try कि हम लोग इन दोनों के सम को 9 कर दें. We will try that a6 plus 6 will become 9. So for that we have to add 3 here. Now here is a thing to observe. The thing to observe is that here we are adding 6 to 3. Now in 5 we will add 4. In this 4 we will add 3. And now sorry. In 5 we will add 5. 4 we will add 5. And in this 3 we will add 6. You can see that now the all sum is 9 and 9 is a perfect square. Similarly for 2. For 2 let's search for the next perfect square. The next is perfect square. So for 2 the next perfect square is 4. So we will try to make this 2 to 4. So we will just add 2 to here, it will become 4. Okay. Now for 1 to make it 4 it will require 3, but 3 is already used, so we will not take it. For 1 again, what is the next perfect square? So for 1 is already a perfect square, so we don't have to need anything, we have to just add 0 and here we will add 1. This is how we are going to do it. Okay, let me just take it again. Let me just take this thing again and explain you guys how we are doing it. Okay, so now let's take a bigger example. Let's take example of till, let's say that our values from 0 to 65. 0 to 65. Okay, means 0, then 1, then 2, then up to 64, 65, 64, 63, 60. These are indices. Means the value of n is 66 basically. That is why the indices are from 0 to 65. Okay. Now the thing is that for 65, what is the next perfect square? So for 65, next perfect square is 81. which is square of 9. Now you will ask her how we can find the next perfect square. So for next perfect square, we can just find first its square root, which is basically, in this case it is 8, and then plus 1, it will be 9, and then find a square of that, which will be 81. This is how we will find the perfect square. Okay, fine. That is what we have used also. Okay, this logic we have used to find the next perfect square. Okay, fine. Now what we have to do is that for the 65, to make it 81, 16 is required. Means in this 65th index we will add 16. Now in the 64th index we will add 17, then 18, then for 62 we will add 19, then till index number 16, at index number 16, we will add 65. This is the thing we have to observe. And now then from index number 15, again we have to search for a next greater element. So again for number 15, next greater element is, means next perfect square is 16. For 15, next perfect square is 16. So to make it 16, we have to add 1. Again for 14 we have to add 2. For 13 we have to add 3. Similarly till for 2 we have to add 14, and for 1 we have to add 15. We have got it. And to make 0 a perfect square, we have to just add 0. This is how we can just make this thing. This is how we have to just make this thing. We are solving this problem. Let's check the code part for better understanding what I have done. Okay. Here what I have done, that I have also first made a very silly mistake. That is why I have got a wrong answer on pretest 1. But then I have just got it at what mistake I was doing. Okay, I was just thinking, I've just interpreted the problem wrongly. Okay, and just think of a different thing. No problem, guys. So first, the implementation of mine is very clear. You can see it is just a while loop. So what I am doing is that I have just taken a map, but which I have not used. Okay, I have just taken it because the logic which I have think earlier uses a map. I've also taken a C, which is also not required. This S is required. This I is also not required. Okay. Yeah, in this answer we are just storing the final array. Okay. So first I am taking this R is equal to n minus 1. Why it is n minus 1? Because our index is from 0 to n minus 1. No? That is why I have taken n minus 1 is in this R. And then I have just taken the until this R is greater than 0. Now using this, what is this is telling? This is telling us this SQRT R is telling us, the square root of the number R, and the seal value is telling us the next number. Just like for value 64, for value 65, its SQRT will give, for value 65 its SQRT will give 8 point something, and this seal will make it 9. Why 9? Because the next perfect square for 65 is 81, which is a square of 9. That is why I am taking here 81. So then what we will do, we will find a difference of that number R with its next perfect square. Means difference of 81 with 65. Exactly like example which we are discussing here. So our next perfect square was 81, and to make it 81, 16 was a difference which was required. Okay. Then what we have done? Then we have just iterated from R to D. And then I have just assigned the value. Means I have taken this S as the S square as the next perfect square. Let me just explain you this thing. What I am doing is that you can see that from this 65 till this 16, we are assuming that the sum should be 81. You can see we are assuming that the sum should be 81, and after 16 again we are searching for the next perfect square. That is what I have done. So from the 65 till 16 index, I have just taken this 81 as the perfect square, and then the remaining sum I have taken it in the array. Okay, great. And then I have just taken it till for all the indices from n minus 1 to 0, and then I have just printed the vector. The way how I am taking input, how I take, like just like here you can see that I have just taken vector input at once. Here I have printed the vector at once. So if you want to also learn this type of techniques, I have a dedicated video on this, my CP template. You can just check it out on my channel, that how I basically do these things. Okay guys, I hope that this explanation is clear to you. If you have any doubt, you can just comment it down, or you can also join my telegram where you can just ask that. Okay, I will try the problem number 4 also, and if I will get it, I will surely upload its solution. Okay guys, thank you for this video. Please share it with your friends. The system testing is not yet started. Okay, so let's wait for it. Thank you.